Okay, back to the code. We're going to change where find 7 to where find 8. Make sure our linear search is looking for an 8, and then change our message. Was found at index location where find 8. Now we're going to make this a little smarter. We're going to show you that it works, so it did what it was supposed to do. Now, let's make this smarter in the sense that, okay, we know that we've got a bunch of numbers in there, right? Let's write a loop, test all the integers from 0 to 9. I've not done this, so I'm probably going to screw it up before I do it right. I'm not going to lie. We're going to test all the integers from 0 to 9, see if they're found in the array. So when I look at the numbers that are in there, if I go 0 to 9, the numbers we're not going to find are? What numbers are not going to be found if I'm testing 0 through 9? 0 and 8. Very good. Somebody's listening. Okay, so let's do the loop. Let's say for, I don't want to call, do I want to call it? I'll just say num. For int, num equals 0, num less than 10. And then I'm going to say, oopsie, I got a boo-boo right there. Num plus plus. Okay, so inside of here, let's make another variable that says int val equals, and we're going to put, we're going to steal this up here. This searches, let's steal it, paste it, but what am I searching for this time? Not searching for 7. Num, very good. That's because I told you verbally that we're going to be testing all those numbers. So let's now make a print statement. And I want to print, let's see, I'm going to print the num. And then I'm going to concatenate it with, how do I tab? \t. Is that right? Does that look right? And then I'm going to concatenate it with what? What's storing my answer of whether or not it was found? See it? What parameter is keeping track of where the value was found, if it was found or not? Val. Does that look right? I guess we'll see. If I was smarter, I would have printed some headings there. So let's take a look and check our answer. So as we said, 0 and 8 were not found. And then you can go through and so 2 was found at position. Oh, something's not right. Oh no, that's right. I'm reading the wrong values. Okay, does that look right? Yeah. See how smart we are? Pretty powerful. All right, let's now jump back to our note packet for a second. So the binary search is more complicated, and the first thing, I'm telling you, it's more efficient, but it has to be performed on an ordered list. So let's go back to our camera. So this is the array we used for the linear search. Now for the binary search, what is required is an ordered list. So when we're talking about order, it means it's been sorted somehow. You can sort either from smallest to biggest or from biggest to smallest. So I'm going to go ahead and I'm going to take the same exact array and I'm going to put it in a sorted order from smallest to biggest. Okay, so we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Did I miss one? Oh, there's 2 4s. Sorry. Okay, so that's my ordered list. Now, it's at this point in time when the code gets a little more complicated. So we're gonna jump into our searches class again, and let's take a look at what binary search is doing. So let's read the comments. Searches the array of integers for the specified element using a binary search. The index where the element is found is returned, or -1 if the element is not found. Wow, that sounds very similar to what we did for linear. The array must be sorted though, so that's new. So we did that. We have sorted order. So let's see what happens. Now the first thing I notice is I have these integer values. I have low, high, and middle. So low is 0. So I'm going to go back to my drawing, and low is 0. Its value is 0. High is numbers.length minus 1. Well, for us, remember x is the alias. So what is the length of our array? 9 minus 1, so that's 8. 8 happens to be the highest index value. Now, middle is a calculation. Low plus high over 8, or over 2. So that's going to work out to be 4. So here's where middle is. Are there any questions? So the moral of the story is these are low, middle, and high are essentially acting like pointers, pointing to certain positions in the array. Now remember your Java math. Remember, if this were 9, for instance, 0 plus 9 divided by 2, since these are all integers, would also be 4. So the algorithm takes care of if you have an odd number or an even number. If you have an even number, it takes care of itself, okay? So don't worry about that. Now, so what's going on here? I got a while loop. So what does this say? Numbers of middle not equal to key, and as long as low is less than or equal to high. So going in, low is less than high, so I got that. And I'm looking for numbers of middle. So let's assume again, let's look for 7 again. Let's pretend we're looking for the same thing. Just make it easier in our brains. Okay, so we're going to start with middle is 4, right? Numbers of 4 is what value? 4. So the while loop says, while this is not equal to key, and key is 7, is that true? Yes. And is low less than high? Yes. So we go inside. Now here is the key to the binary search working. This is the most important step. So it says if key, which is what? 7. If that's less than numbers of middle. Numbers of middle is 4 the first time through. If that's true, I recalculate high. Is it true? Is 7 less than 4? No. So we do the else. So then we recalculate low. So the low becomes the middle, which is 4, plus 1 is 5. So what the heck just happened? So now, if I go back to my drawing, I wish I had a different color. Okay, I'm going to stop. Good time to stop.